Thank you. Okay, you have made it so far, so congratulations. And now I'm going to speak about a super fun topic, statistics. Woo! Okay, my study is called Smaller Estimation of Forest Attributes. My name is Bernardo, and Francisco Mauro and Francisco Rodriguez are my PhD directors. And I'm going to talk about forest inventory, which is the goal of forest inventory is to get good estimations of forest attributes. As well as said Lord Kelvin on early Twitter, what is not defined cannot be measured, and what is not measured cannot be improved. So the goal of the forest inventory researchers, which I am included, is to get better and better and better estimations of forest attributes. So a new method has born. Smaller estimation is a set of methods, in fact, that were born in like the 80s, but has started to be widely used in forestry, especially in 2000, since 2011, more or less, partly due to the emergence of new technologies, mainly remote sensing, and partly due to the need for estimating subpopulations. That is something that we frequently do in forestry. So, what is this smaller estimation? It's a statistical field that provides a comprehensive framework for estimating subpopulations when sample sizes are small. So basically, it's a method or a set of methods to estimate subpopulations. And it's important to know that sample small refers to the sample size and not necessarily to a surface area. There are many methods or smaller estimation methods. We are going to focus on the most prominent ones that are model-based methods, and we have two of them. There is the unit level and the area level methods. So this work has the main objective of compare a traditional method approach, which is a direct estimation of the forest attributes, and we are going to compare this method with two smaller estimation methods that are the unit level and the area level methods. Where is located this study? It's located in the limit between Soria and Burgos. We have a forest of 91 management units or stands, and we have a total of 119 plots. Let's compare these methods conceptually. The traditional method is the direct estimation, in which we want to get estimates for the target stand, that is the darker one, and we have, for instance, 3 plots within the stand. So we're going to get an estimation that is unbiased but has a large variance. It's unbiased because we are using data from within the plot, but also because we can control the sampling design. And it has a large variance because we only have data from 3 plots. And it's important that we are not using auxiliary variables in the traditional approach. And in the smaller estimation methods, we are going to get estimates of the same stand, the darker one, but in this case, we're going to use information of all the plots of the forest area. So we are going to use information from 91 plots that are borrowing strength to our estimation. And we are using auxiliary variables, mainly LiDAR data, and we are going to use mixed models. And we are going to get an estimator or estimate that it's going to be unbiased and it's going to have a small variance. We have heard a lot about mixed models in this Congress. I'm going to try to explain to you in a very simple way. We have, for instance, this regression model that were fit with data coming from 4 different stands. Each color represents a stand. But what happens when we want to predict, for instance, this stand's value? We probably are going to overestimate the values because the regression line is over our data. So the mixed models basically what do, and that is the magic of the mixed models, is they calibrate a model for each, we could say it's a submodel for each stand. So we are going to get unbiased and more accurate information for each stand. Okay, but now not so fast brainies. This is just a statistical framework. Remember that we had two models, the unit level model and the area level model. Let's talk about them. Both are model-based methods, which means that basically we are going to fit a model. In both, we are going to use a dependent variable, that is information coming from the plots, and we are going to use independent or auxiliary data, that in this case is LiDAR data, that is the raster file that is in the background of the image. And in this toy example, the circle is our subpopulation of interest, and the plots are the plots, the yellow dots. In the unit level models, each pixel is a population unit. It's important the plot's area is equal to the pixel area, and we are going to fit a regression model in which each plot is the dependent variable, and the independent variable is going to be the LiDAR matrix of that pixel, or the same pixel. And once we have our model fit, we are going to predict the values for all the pixels of the subpopulation of the circle. So we are going to get an estimation of the whole subpopulation. And the area level models, also called the Feijer models, the unit of analysis is the subpopulation area, or the stand, that is the whole circle. And in this case, we are going to fit a regression model that uses the mean of both plots. In this case, is a dependent variable, and the independent variable is going to be the mean of all the pixels. Finally, we are going to fit a regression model and get estimations for the stand also. And now the good stuff, the results. We are going to, we got estimations for 3 variables: basal area, total volume, and number of trees. These were done getting the mean estimation for each stand, and after that, getting the mean estimation for all the stands, and we get these values. We can see that we have the estimation on the left and the uncertainty of the right of each method, and we can see that as we go to the right, the uncertainty gets lower or decrease. This is important of the smaller estimation methods. We get better accuracy and less uncertainty. If we compare the methods, we can see that the traditional approach, for instance, is relatively easier. We can get unbiased estimations, and we don't need a GPS. The smaller estimation method, the area level, it's relatively complex. We also get unbiased estimations, and we don't need a GPS. So this is very important, and this is why this method is frequently used, because we don't need very exact locations. And the unit level model is relatively complex. It's unbiased, gets the best uncertainty, the lower uncertainty, and the most accurate results, but needs very good and precise locations. So this is why frequently it's not used, because it's not so common that we get so good plot measures. So some take-good messages. Smaller estimation provides tools to get unbiased and accurate estimations when sample size is small. This is very frequent, at least in the forestry sector. And I get it. It's harder and requires training, maybe a lot, but results are much, much better. And be good. That's all I have to say to you. Thank you so much.